Building retuning training was conducted by Ron Underhill and Gupong Liu, scientists at the Pacific Northwest National Laboratory. Classroom and on-site training for Maryland State Agency facility managers was conducted at Towson University in Towson, Maryland on June 17th through the 19th, 2014. This segment of training covers Introduction to the Building Retuning Process.
This training is called Building Retuning. Just by way of introduction, we're from Washington State. We're from Pacific Northwest National Lab, PNNL. It's one of several, almost a dozen multifaceted national labs that the Department of Energy funds. Our national laboratory is located in Washington State. This is a little picture of where we're at. We've got almost 4,000 employees, staff. They're involved in multidisciplinary research in lots of areas: environment, energy, buildings, security, national security, and so on and so forth. We're located on the Columbia River in southeastern Washington State. Shameless plug for Washington State, Idaho. If you guys like to eat French fries, Five Guys restaurants is big out here. If you've ever been to Five Guys, they always say these are where the potatoes are from. A lot of them are right from that area. So eat lots of French fries, please. You're helping our economy. But anyway, that's all I'll say. Columbia River, lots of hydroelectric energy. We do a little bit, quite a bit of wind and renewables out there, but probably not as much as in other locations of the country. Our focus is on building retuning and finding ways to use your buildings to, I keep hitting the wrong button there. There we go. I'll get it right. This retuning question was asked, what is retuning about? And we're going to talk about it in depth as we get going. But it was originally funded by another state agency. A lot of you are with state agencies with Maryland. The Washington State Energy Office and other organizations within the state level funded this. Quick story, Enron, everybody knows about the energy crisis, early 2000, 2001, 2002. California and the West Coast was seeing significant energy prices increasing 2, 3, 4 times. It was a lot of speculation, and there was eventually a lawsuit, and monies were funneled into several states, and Washington State did several things. One of them was to fund this retuning training. And so originally it was delivered to the state, I think we heard General Services, GSA, so we went to the capital of Washington State, which is Olympia. We dealt with a lot of the state organizations that are represented here today and delivered this retuning training. So a lot of what we're going to deliver today has been modified and improved. A lot of this has been converted to online interactive retuning training. And we have 2 facets. One is for large buildings. We call it large building retuning, which generally implies that that building has a BAS or an energy management system. Some of you have energy management systems, some of you don't. Some of you are about to get energy management systems. So we're really going to focus on building retuning as it relates to an energy management or building automation system. For those of you that do not have, maybe you have a smaller building. A lot of smaller buildings are primarily packaged rooftop units, split units. They might have a programmable thermostat. There might be some other things. We have another training. It's small building. We call small building retuning. It also has its own training. But both of these have, whether it's a large building or a small building, a BAS or a non-BAS, they have an online interactive web training. And you can go to these URLs shown up here. And everybody should have gotten a link to the slides. Is that right? Yeah, okay. So a lot of this information you already have. And there's training guides that are specific for the BAS sections that we're going to talk about today. So what we're really after, the objective is to provide principles, really, foundational topics related to large buildings, the BAS systems, and how to retune. Now, when we say retune, what we're really talking about is low cost, no cost. And we'll get into, there are some differences between what we would call recommissioning and retuning. And as you said, what is tuning? I just want to tune. If you just want to tune, that's fine as well. This was just a term that came up when we were trying to give a name to this training. And originally it was designed to be delivered to service providers. Some of you deal with controls companies, mechanical service contractors and such. And we did deliver this training up in Washington State to those types of organizations. Some national control companies have also participated in this training as well. Some of them do have something, they've obviously massaged it to fit their delivery systems and their sales systems. So you may or may not see something like this from other companies that you deal with in the controls arena, whether it's Siemens, Johnson, Honeywell, etc. So let's talk about retro commissioning. A lot of you are involved in retro commissioning or commissioning, and there is a perception in the field that it can be expensive, which is true, it can be. Typically though, it has less than a 3-year payback. And there's also a perception that the measures, the energy conservation measures that come up in a retro commissioning process do not persist for a very long time. Sometimes you identify something, you deliver it to the building owner or to the person who's managing the building, and they make the change, and then it goes away after 6 months or less. And what we find in buildings is typically there's a lot of persistence gaps. Some of it's related to training, and that's why we developed this training. And there's a lot of reasons for that. So we'll talk about some of the reasons for that. Generally what we see amongst other things is you guys just had a really cold winter. And from an operations standpoint, operators are people who can do things. You know, we're all can-do people, and if it's cold or extremely hot, now you're getting into some hot, humid weather, if the phone's ringing, most of our operational staff are responding to occupant complaints, and the quickest way to respond to that is to do things to the building automation system or your HVAC system. It could be overriding set points, it could be overriding schedules, it could be doing a number of things. It could be even going out into the field and bypassing the building automation system completely. So what we're trying to do with retuning is basically say there's a way that you can fill this gap of persistence and extend that savings and basically identify intermittent problems that would normally come up and do it at a fraction of the cost. If we're going to have to wait to have someone come into our building to re-audit it, to recommission or retro-commission it, and if that happens once every 3 to 5 years, that's a long gap of time where we're losing that persistence. So this chart here basically shows how energy consumption would over time typically rise based on a building's behavior. And typically it would rise over time for a lot of reasons. It could be equipment failures, lack of maintenance, how we operate the building, the mission, it might have changed. And so that's typically what we see. If we have a recommissioning effort, we may see it drop momentarily, and then again over time it would start to increase, and then we would see someone come back in and recommission it. And so what we're trying to do with retuning is find a way to fill that gap. So continuous retuning, and someone will say, well, how often do I have to retune or tune my building? And we really don't tell you that. What we would say is tuning, retuning is basically something that is an internal process to your organization. It means you're continually looking at the meter data, you're continually looking at your HVAC systems, your controls, how you maintain, how you operate your buildings, and you're saying, is there something that indicates things are starting to get out of bounds and we need to go look? So really what retuning is, it's a systematic process to identify and correct operational problems that lead to energy waste. That's, in a nutshell, really what it is. Implemented primarily through your BAS, building control system, at no cost other than the labor to perform the retuning activities. So for a lot of organizations, we would say you already have people in-house and your staff potentially, like Towson does. Some of you may not. You may have to go out and hire some of those people, but if you have people that are in-house that can already they're already managing your building automation systems, they already have access to things like trended data, then they can do some of these things that we're going to talk about today, tomorrow, and Thursday. There may be some repairs that are required, low-cost repairs, faulty sensors, perhaps an actuator. It might be a damper or a valve. But what we've seen, and we'll show this in our slides, if we let those failures persist, it might be a $100 or $200 failure. It can end up being 10 to 20 times that in energy. There may be other opportunities that are identified when we do retuning. It may relate to an engineering design change. But it's important to get out in the field. It's important to use the BAS as a means to capture some of those things that would otherwise get lost. So the bottom bullet there, we think of it as a scaled down retro commissioning effort. And retro commissioning, for those of you who've done those types of efforts, it's very detailed. It often involves a lot of paperwork. It often involves walking down all your HVAC systems, envelope, lighting, et cetera, et cetera, et cetera. And if you want to go to that level of detail on a tuning effort, that's fine. But what we really are emphasizing with tuning or retuning is to really focus it on the BAS. These are some of the areas that we would focus on in retuning. There may be some other ones. And we recognize that some of the things that we've listed here exclude some other areas that might be particular to your building operations. But primarily, scheduling is the biggest one. We consistently see buildings that are operating 24/7 or near 24/7 over holidays, over weekends when no one's in the building or very few people are in the building. How do we wrap our arms around that? We know there's an opportunity there, but how do we get our arms around that? Temperature control, static pressure control, heating and cooling. We find a lot of heating and cooling simultaneously occurring. They mask each other. The end result is we get the proper temperature coming out of the diffusers in the ceiling. Occupants in the space are happy, but what's going on? Why are we heating and cooling at the same time? Are we even aware of it? How's our economizers and our ventilation systems? Are we over-ventilating? Are we under-ventilating? Do we got demand control ventilation? How's our economizers? Are we bringing in outdoor air when it's proper, economical to do so and reduce or eliminate our mechanical cooling loads? What's going on in our zones? Are terminal boxes separate? Do we've got perimeter hot water? Are they sequenced with each other? And finally, what's going on with the meter? Because the meter is what's telling us how well we're doing or not doing. Now, I was very fortunate that when I got to my hotel room, there was a nice hotel room, but there was no scale. And I'm not afraid of scales, but my wife is after me to lose weight. And so this was great. I don't have to worry about what I eat this week because I have nothing to measure my body weight. So it's a good week. When we have meters, those of us who are involved in wanting to see whether our buildings are performing well or not well, that's the bottom line. And so if we're not looking at what's going on a weekly or monthly basis, we might be losing some opportunities. And I personally would like to be able to tell my wife, I'm only going to jump on that meter, the scale, once a month, maybe once a quarter. Because that's typically what we see in buildings too, right? So I think it should be the same for us as individuals. No, we want to keep track of what's going on with our buildings and the meters. That means we've got to have reliable meters. There's been a big emphasis in the federal sector, different agencies, DOE, GSA, DOD. Some have done really well putting in good meters, quality meters, some not so well. Hopefully all of you have good meters. Hopefully if you don't, you're able to get some good meters. And then the last area that we want to focus on is central plant. A lot of organizations like Towson, some of your organizations that you're from, you have central plants, whether it's hot water, steam, or chill water. And how are those operating? Are they operating efficiently? Are there times of the year when they could be shut down? We still emphasize shutting down chill water plants if they're not needed in the middle of winter, hot water steam plants if they're not needed in the middle of the summer. And those are opportunities, but there's a lot of challenges, and I'm sure we could spend a whole day talking about why we can't shut down our central plants. So we're not going to do that today. We might at the break. Those are the things that we're going to go through and talk about. So these are the 6 areas. We probably won't spend a lot of time on the last one, but the first area is collecting initial building information. Most of you already know most of the basic building information. Then trend data. Again, our focus is on building automation systems, so we want to collect some data. We did collect some data for Towson, about 2 to 3 weeks worth of data. We'll talk about one of the buildings on this campus this afternoon. And then walking the building down, that's how we get to know the building. And then identifying and correcting operational problems. And then the last one is reporting the findings. That includes the meter data. Did we move the needle in the right direction? Did it go the wrong direction? Were we successful? So again, we've already talked about the purpose of retuning. It's primarily low cost and no cost, and everyone has a different definition. What's no cost means there's no cost. It's already embedded in your operations, either in your in-house staff or you've got a contract with somebody, you've already paid for it. Low cost, I'm not going to put a number on that. Somebody always says, well, what's low cost? Give me a number. Is it $1,000? Is it $10,000? I'm not going to tell you. That's up to you guys to decide. But what we're going to say is it's something that you would not normally have to go out and it's not going to be an ESPC or EPC or whatever you want to call it. Something that hopefully you can budget for. Again, identifying opportunities to increase your building's energy efficiency and looking for those things that do require repairs. Hopefully that would be on your service or unplanned or planned maintenance activities. So again, the last bullet there is we want to catch the big energy saving opportunities. And we're basically going to say it's in your operations. So we have some definitions. Retro commissioning, recommissioning, continuous commissioning. We've already talked about some of that. Retuning, our definition of retuning is that it's a no or low cost method to save energy. And the methodology is focused on low and no cost operational improvements. So we're primarily talking about your operational staff, your O&M staff. Again, it's pretty much related to setting up your control systems to some known design, configuration, set points, schedules, and algorithms if they need to be added to achieve hopefully a better building. So the question really is, how do we know what these set points and configuration values are? Were they determined by the engineer when he developed the plans? Was it from the building owner? Was it tribal knowledge from the service technicians? Was it from the operators? Did it come during the last cold weather event or maybe this summer when we get a hot weather event? Basic energy management from a retuning perspective, real simple. If you don't need it, turn it off. If you don't need it full power, turn it down. So, okay, most of us understand, okay, light switch, don't need it, turn it off. Motor, you can turn it off at a motor control center. What are some things, I'm just going to throw this out to the audience. What are some things that we can turn down when you think about a building?
Hot water reset.
Hot water reset. You can turn chill water reset.
VAV, I assume that
VAV.
most of these folks are running
Yeah.
very reliable.
If you've got VFD-driven equipment, fans, cooling tower fans, air handlers, pumps, all those, the VFD stands for variable frequency drive. That means you can vary the speed, which means you can vary the capacity, which means you're varying the energy consumption. Dimmable lights, if you've got dimmable lights, those are some of the areas. Hot water reset, a lot of these things are limited. Some people say, yeah, but I don't have condensing boilers. If I reset my hot water loop too low, I'm going to have problems with condensation, and then I'm going to have other problems in the boiler, and that's true. And we're not asking anyone to do something that's going to cause damage to your equipment. Okay, number one. But what we're saying is we need to recognize there are some opportunities. Discharge temperature reset. We typically find 55-degree air, 52-degree air coming out of air handlers because that's the target set point that was determined by an engineer. And it's usually based on a design day, 95 degrees outside, 80% humidity. And do we have those conditions year-round? No. In fact, this winter, we were out here on the east side of the country. We were in the south, and you guys had some really cold weather. And we were finding people were freezing coils because they didn't know how to manage cold weather. But what we really found that was astounding was the set points coming out of the air handlers, 52. So it was obvious that the controls were configured for a design cooling day, and it was actually a design heating day, but nothing was set up in the controls to alleviate that. So there's some opportunities. Shoulder months are huge. We're not saying it's a great opportunity to save energy on a 95-degree day. No, it's not. That's when we expect to expend a lot of energy. What are we doing in the shoulder months?